Hey guys, this question asks, what is the absolute stereochemistry of the starting material and product in the reaction shown? Okay, so remember when we do absolute stereochemistry, we use what is called the Kahn-Ingold system. And basically what it is you number your substituents around a chiral atom. And then what you do is you put the fourth group, the group with the lowest priority, in the back. And then you pull basically a circle connecting the other three. And if that circle is going to be clockwise, then it's an R configuration. If it's anti-clockwise, it's S. Okay, so let's do that real quick here. Iodine is going to be number 1. Fluorine will be 2. And here we have 2 carbons. But this carbon has 1, 2, 3 hydrogens on it, whereas this carbon has another carbon. And carbon beats out the hydrogen, so this will be number 2, and this will be number 1. All right, now I want to put number 4. Sorry, this should be number 4 and this should be 3. Sorry about that. This should be 3 and this should be 4. Okay, because this carbon beats out the hydrogen. All right, now I want to have number 4 in the back, this line here. So I want to pretend I'm standing here looking at this compound directly onto that carbon so that I don't see that back carbon over there. So if I do that, what would I see? I would see the ethyl group kind of below me. See, I'm in this same plane as the straight lines, right? So the ethyl would be right below me. And to my right then would be the fluorine, and to my left would be the iodine. Like that, okay? And now if I connect them, this is going to be 1, this is 2, and this is 3. So this would be clockwise, so this compound is R. Now take a look here. Now we do the same thing here. Now, most people, there's a sort of a trick to this question, because you would think this is going to be a backside attack, right? NaOCH3, strong nucleophile, come in, do a backside attack, kick out the iodine, and you get an inversion of stereochemistry. So if this is R, then this one should be S. But be very careful, because sometimes it depends on what is now the priority. See, here the fluorine was number 2, but here, since you're replacing iodine with an oxygen, now fluorine will be number 1, and the oxygen will be number 2. And this will be 1, 2, and this will be 3 still, and this will be 4. And looking at this, you can see, oh, it's exactly the same. The 2 is in the back here, the 1 is out to the front, 4 is to the left, and 3 is to the right. So these two will have the exact same stereochemistry, so this will also be R. So both compounds, therefore, will be R. Okay? So that's why when they talk about SN2 reactions and those backside attacks, that's why they say it is an inversion of configuration. They could have said it's an inversion of stereochemistry, and a lot of people mistakenly actually say that. You might have even heard me say it in a video, because generally, when you invert the configuration, you also invert the stereochemistry, because typically the nucleophile will be something that's a high priority group, right? Something like sulfur or whatever. And the thing that leaves, the leading group, used to be the high priority group, something like iodine or bromine. But that's not always the case, as this example shows, okay? So the answer here, therefore, will be it's an inversion of configuration, but in this case, the stereochemistry did not change. So we started with an R and we ended with an R. So both compounds have R configuration. Answer choice B, therefore, will be correct. All the other answer choices are incorrect. All right, thanks, guys. This is a great example to go over. Make sure you understand exactly what I'm talking about. Make sure you understand exactly what the difference is between the configuration and the stereochemistry. If you have any questions, shoot us an email. We'd be happy to explain things in more detail. Thanks for watching this video, and we'll catch you in the next one. Have a nice day.